Hello everyone, welcome back to my channel Cat by Nagendra. So from this tutorial we are going to start with sheet metal design. So let's see basic introduction of sheet metal design and how to create design and what are the design considerations, entire step by step in this tutorial. Now sheet metal fabrication is a process of forming parts from a metal sheet by punching, cutting, stamping and bending. So before we have seen how to create solid models. So those will be done by using machining operations like by using CNC machines or different type of machining operations we are going to make with solids. But now we are going to learn about sheet metal. So sheet metal is nothing but here, as you can see, sheet metal fabrication is a process of forming parts from a metal sheet. We are not going to use any solids here. So just with less thickness of 6 mm, less than whatever the sheet will be having thickness of 6 mm. By using that sheet, we are going to create parts by using punching operation, cutting, again stamping and bending. Now, next you can see here 3D CAD files are converted into machine code which controls a machine to precisely cut and form sheets into final part. So first what we will do by using any 3D CAD software, we will generate which design we wanted in sheet metal design. So then that will be converted into machine code. So usually the process will be like, so after creating like solid model or after creating this forming sheet metal part, what we will do is we will make flat pattern. So after making that flat pattern, we will convert that file into DXF format. So that is a file format which we can save that file. So the DXF file format, if we upload in laser cutting machine, so that will be converted automatically from a 3D CAD model to machine code like CNC programming, like that it will be generated. So with that help of CNC programming, laser cut, it will cut whatever the shape we wanted. Later we can go for bending and forming operations. So one by one we can see now. Then sheet metal parts are known for their durability. So durability will be more for sheet metal parts, which makes them great for end use applications. Example chassis. So for four-wheeler and two-wheeler, if you can see, so especially for four-wheeler we will be using chassis. Outer frame designs and all will be done by using fabrication process only. So parts used for low volume prototypes and high volume production runs are most cost effective due to large initial setup and material cost. Why? Because compared to machining operations like CNC machine, like that, compared to that, so this will be little less cost and wastage of material also will be less when compared to solid models. Then because parts are formed from a single sheet of metal, designs must maintain a uniform thickness. Be sure to follow the design requirements and tolerances to ensure parts fall closer to design intent and cutting sheets of metal. So here one drawback we need to remember that. So from when we are going to create a 3D model or something, so we are able to maintain different thickness at different positions. But if you are going with sheet metal fabrication, entire sheet should be with the same equal thickness. Why? Because one big sheet we are going to take and we are going to cut whatever the shape we want. Later we are going to bend it. We are not going to add one more sheet to this. So that you need to remember. Then applications of metal forming. So where we are using the sheet metal design means, as you can see, we are using sheet metal fabrication in automotive industry. So in automotive industry we can use for body panels, again chassis components, engine parts, exhaust systems. Then under aerospace industry, chassis members, body parts, engine parts, landing gear, structural components. Then in pressure vessels for boilers and fuel tanks and storage tanks also we are using. Then pipe and tube means we are using conduit, again drainage pipes, again gas pipe, water pipe, like that. In various applications we are going to use this sheet metal fabrication. Then sheet metal fabrication stages will be there. So sheet metal fabrication comprises various processes and operations. This process can be classified into following manufacturing stages. One is first initial thing we need to design. So why? Because before going to generate or before going to make production, first we need to see that prototype, how it is there and how it will be able to come. So first we will design by using any 3D CAD software, and we are able to see that output shape. Later we can go for fabrication. So fabrication involves a different process again one by one we can see in next slide. Then after that, at the end we will go here with this post processing and finishing. So after that we need to go for finishing, and I'll say like 3D model machining operations. Then first we are going to see here sheet metal fabrication processes. So sheet metal fabricators produce metal parts and structures from metal sheets using numerous operations and processes. These operations are classified into following. So I am not going to elaborate this. Why? Because I have used simple words for better understanding. So just if we read it, we can understand what is the meaning of that particular thing. So first we can go here with this cutting operation. Cutting will be done by using various methods like water jet cutting, laser cutting, plasma cutting, mechanical sawing, like manually we will saw it. Then or else with machines also, sawing machine will be there. Then shearing will be there. So in sheet metal fabrication, mainly we will go here with this laser cutting machines will be there. Why? Because we will get accurate shape when we are going with laser cutting. Then after cutting, we are going to perform forming operations. So under forming, we are having bending, stamping, rolling, deep drawing. So bending is nothing but in whichever the angle we require, in that angle we will bend. Stamping means in different shapes, we can just make it with the press tool. Stampings we can do. Again rolling we know. Then deep drawing. Then next we can go for joining and assembly. So for example, two components or big components are there. At a time we are not able to make that. So one shape we will create with one sheet and one more we will create with one more sheet. This both we need to join now. So for joining and assembly, we can go here with welding operation, then brazing operation and soldering also we can do, or else fastening operation and adhesive bonding we can use to join or to make assemble different parts to make a single part. Then after completion of this fabrication process, next we can go for post processing and finishing. So remember, first we are going to design, then next we are going for fabrication. After fabrication, we are going to go with post processing and finishing. Then under this post processing operations, we are having annealing, tempering, normalizing, again through hardening, like nothing but quenching, again case hardening, nothing but carburizing. So these are the post processing. After completion of cutting, bending, forming, stamping, everything, later we are going to make here post processing. Then again after that we are going to make it finishing operations by using bead blasting. So usually we'll make here with glass bead blasting. So glass particles will be there with like sand. So with the high pressure gun, we are going to push that glass beads onto the surface. So because of that force, that entire surface will come shining and extra it will finish will be nice. Then powder coating we can do, anodizing, electroplating, chemical coating, like the different type of process we can obtain by which we can get whatever the finishing we required. So this is about finishing operations. Now from here, this is the main thing. So sheet metal thickness is important. So sheet metal thickness should be chosen to ensure the part has the required strength and rigidity. So according to our requirement, what is the strength we required and what is the rigidity we require, according to that we need to select the sheet metal thickness. So usually standard sheet metal thickness typically range from 0.6 mm to 6.35 mm. So whatever the part we are going to generate by using sheet metal design, that thickness should be between 0.6 mm to 6.35 mm. If that is the thickness we are having, so then it can be done by using sheet metal fabrication. Then selection of material is important. So material here, choose materials that are suitable for intended fabrication process and application. See, sheet metal is nothing but we are going to cut and we are going to bend. So whatever the material we are having like less brittleness, so if you try to make bend, it will cut. So like that we need to think and we need to select the material according to our requirement which is suitable to make by using sheet metal fabrication. Then consider the material properties such as its ability to withstand stress during bending and welding. Yeah. So while making bend, so here it should be withstand that stress. Why? Because while making bend, stress will be applied on that particular position. So it should be able to withstand that stress. Example, stainless steel we can use, mild steel, cold rolled steel, galvanized steel, aluminium, brass, copper, so etc. So like that different type of materials we are going to use while making sheet metal fabrication. Then before we have seen after making laser cut we need to bend that. So to bend that we use here punch press, nothing but bending machine. So simple layout you can see here. Hydraulic ram will be there. So with hydraulic pressure it will be operated up and down direction. Then punch will be there. So punch is nothing but whatever the shape we want to make that sheet metal bend, so that punch will be inserted here like with a different type of angles. Then back gauge will be there. It is nothing but like support at bottom. Then die will be there. So whatever the output shape we want, that die will be there. Now die is there, sheet we are keeping here and we are able to press that. We are that entire pressure it will apply on that sheet. Then if it goes compression, so under that compression whatever the die we have kept and whatever the shape we are having for that die, same that shape will be obtained in this sheet. Then this is bed, this is like base. Then sheet metal bending we will see. So bending is a process whereby a force is applied to sheet metal which causes it to bend at an angle and form the desired shape. Bends can be short or long depending on what the design requires. As before I told, here die is there. In between that we will keep sheet. Upon that we are having hydraulic ram. When this hydraulic ram comes down, so that hydraulic pressure will be on this sheet. So already we know that this sheet thickness is very less. So when this pressure comes onto that sheet, whatever the die shape is there, within that shape the sheet will be bent. So whatever the shape we are having, that shape we are going to get that output. Then bending is performed by a press brake machine that can be automatically or manually loaded. So press brakes are available in a variety of different sizes and lengths, 20 to 200 tons depending upon the process requirements. How much pressure we need to give here, so that machines we are having on different lengths and sizes according to our requirement we are going to purchase. Then as you can see, this bending we are getting here. So that bending we are having this shape. Now when you are going to bend one sheet, so you can see this is the flange length. So after bending this is one side and this is one more side. So you can see here whatever the distance or dimension we are having from this end to this end, so this will be the thickness of the sheet. Then in between that exactly one line will be there here. So this line we call it as neutral axis. Then after making this single sheet bend like this, so this whatever the angle we are having getting here, that we call it as bend angle. So while making bend, exactly we will get here some curvature. Why? Because we won't get here any sharp corner. So for example, if we try to any paper we can take, let's take for example one paper I will take. So this will be less thickness, just for reference I'll take. For example, we are having one paper here. So this page, so let me maximize the screen. So this page, if I try to bend here, you can see here small gap will be there. As you can see, one curvature will be found. Why? Because sharp edge we won't get here. So here only in microns thickness is there. For this microns only we are getting little radius. Then if you go here with this thickness of some 2 mm or 3 mm, definitely it will be with curve format. So that curve we call it as inner radius. Then distance from any end to this neutral axis, this we call, so this neutral axis distance we call it as capital T. So this will be the bend line. So where we are going to make this bend, where it will occur, that we call it as bend line. So next you can see here. So what is meant by bend line? What is the bend radius? What is the bend angle? As I have explained before, it is with the theoretical format. So just you can pause the video and you can read it once. Then about this K factor, again next slide it is available. There I'll explain. Now K factor. So what is meant by K factor? So K factor is nothing but it is the ratio between the neutral axis to the thickness of the material. So K equals to capital T by small t. So as you can see here, this is the neutral axis distance. So capital T by thickness of the sheet. So then we are able to get K factor value. So here, what is the importance of K factor in sheet metal design? What is the use? So as you can see here, a K factor is used to calculate flat patterns because it is related to how much material is stretched during bending. So usually we'll be having like flat sheet. So for this flat sheet, we are going to bend like this. So that one we need to calculate K factor. Why? Because how much material is stretched during bending. So if K factor is very less, then this it will become like tear options like this. It will go and we are can't able to bend this. So in such conditions, we need to maintain this K factor value within the limits. So therefore, it is important to have the value correct in CAD software. The value of the K factor should range between 0 to 0.5. So always K factor value should be 0 to 0.5. More than that, if we are having, we will be not able to bend that sheet metal. So to be more exact, the K factor can be calculated taking the average of 3 samples from bent parts and plugging the measurements. So this you can see just a theoretical formula it is there. So K equals to 180 by bend angle. So like that we will get proper this thing, but no need to take tension. Why? Because in our CAD softwares automatically if you give thickness of the sheet, automatically it will take what is the K factor required. I'll show you while creating a like sheet metal parts by using SolidWorks or CATIA. Then bend radius. So bend radius also very important. As we have discussed earlier, minimum bend radius should be at least equal to the sheet metal thickness to avoid cracking. Let's say for example one sheet is there. So this sheet thickness we are having 2 mm. So if we are able to try to bend this sheet metal exactly like somewhere we will get one curvature here. If we are not able to get that curvature, it will go with dropping like cracking and it will get a tear off. So always we need to remember that minimum radius, bend radius should be equal to at least thickness of the sheet. So normally if we bend also, whatever the sheet thickness is there, minimum that bend radius we will get here. Then larger bend radius are generally preferred for easier bending and reduced stress connections. Now thickness is 2 mm is there. If you consider 2 mm only, okay. More than 2 mm like 4 mm or 5 mm if it consider, again it is very easier for bending operation. Properly we will get that bending shape. So you can see this is not good. Why? Because sharp edge we won't get. Now this inside radius we will get here, then outer radius we will get here. Now let's say this sheet thickness is 2 mm, then bend radius minimum I am maintaining here 2 mm. So outer radius will be 2 plus sheet thickness, outer radius we will get 4 mm. So just for considerations we can see this. Then flange length. Minimum flange length should be there. So flange length should be at least 3.5 times of the sheet metal thickness or 3T plus R. So here 3.5 times. Now as I have told earlier, for example, if we consider 2 mm thickness, so this flange length should be minimum 3.5 into 2. Like minimum length should be 7 mm after bend to end like this. RS 3 into T. So 3 thickness we are having here 2, 3 into 2, 6 plus bend radius 2, total 8. So 7 to 8 mm we should be having this flange length. then only we are going to make this bend. Then consider using flanges and dimples or beads to stiffen the bent parts. So after, like for making bending, if we are using dimples or beads, so this is nothing but dimple. Beads means again one different shape it will come that we are going to see in software. So this will improve the stiffness of the sheet. Then hole size and spacing. So these are here also some considerations, limitations will be there. Hole diameter should be at least as large as the sheet metal thickness to prevent damage to tooling during punching. So whatever the hole we are going to create here, that hole diameter should be minimum, at least it should be larger than the sheet metal thickness. Let's say for example thickness we are having 2 mm, so that diameter of the hole should be more than 2, like 3 mm, 4 mm, like that. So smaller also now possible. Why? Because we are going to perform with laser cutting. Accurate dimension we can get. Not a issue. Then minimum spacing between holes should be 2 to 3 times the sheet metal thickness to prevent deformation. Here you can see 2 holes, like multiple holes if we are having. Distance between one hole end to one hole end, minimum it should be 2 to 3 times of sheet metal thickness to prevent deformation. Why? Because later if you go for bending, again it will get a drag. This circle shape it will become oval shape. So to avoid that, these considerations will be there. Then holes should be placed a minimum distance of 3t plus r from the edges of the part. Now, for example, this part is there. We can't create one hole here near to that. Why? Because again, if we are having any bend, if there is no bend, no problem. But if we are having any bend here, so later by creating this hole at end, and if you are going to bend here, that again circle shape will be like dragged and it will become different shape. So minimum distance should be 3 into thickness plus bend radius from the edge of the hole center. So from this edge, it should be minimum distance. There we can create these holes. Then bend reliefs and fillets. So use reliefs or fillets at corners to prevent stress concentrations and cracking during bending. While making bending, there should be fillets and relief should be there. So this relief I'll explain in software. Like what is meant by relief means, let's say for example, one sheet we are having. So like this one sheet is there. So this sheet we have folded on 4 corners. Let me show you. Like this, any square box if you are going to perform this, whatever this edge is there, no, so here this corner we can't get properly, so here some material will be removed by using stress concentration. So there relief we will give, that relief will be of different types, like rectangular relief is there, circular relief is there. I'll explain in you software. Why? Because practically if I tell you like this, you won't understand. So in software, you will get clarity on that. Then design dimples or embossments strategically to add a strength and improve the part aesthetics, as we have discussed before here. So like this dimples and the beads should be there to stiffen the parts, and it will improve the aesthetics. Like look wise also it will get improved. And this bend radius, as you can see, if we are having here sharp edge, for looking it will be not good, it will be like little odd. So if we are having curvature, for looking it will be good. So good improve for aesthetic wise also. Then relief of a pen should be at least 2 times in width and bend radius plus t for length. So this what is called my relief. So here also you can see this is rectangular relief, this is circular relief. I'll show you in software. Then avoid design with very deep draws. So like for example, if you want to create some parts like this by using sheet metal fabrication, it is little impossible, like it will be difficult. Why? Because more curvatures and this entire shapes we can't get accurately by using sheet metal fabrication, but in plastics or die casting methods we can get. But in fabrication is nothing but Like we are able to cut the laser cutting, then we are going to bend. So by bending only we need to get, or else by using press tool, like we are going to make punch. But smaller shapes we are able to get that punching. It, like this intricate shapes we can't get. Like in our home we will be having some different type of vessels, utensils, that will be done by using punching only. But in different shapes, like let's say for example any intricate shapes with the different designs, that will be not possible by using sheet metal fabrication. So only we should avoid this type of designs by using sheet metal fabrication. So then finishing sheet metal parts. So as we have discussed, different type of finishing operations are there. It includes sand blasting, which consists of shooting jets of abrasive material at metal to roughen and clean the surface. So sand blasting is nothing but abrasive material, like little grains will be there. With the force we are able to pressure, with the pressure we are going to force it onto the surface of the sheet metal, so that will remove roughness and it will clean the surface. Then brushing is similar to sandblasting in function but uses abrasive brushes. Here we are using abrasive material grains, here we are using brushes, just like we will make a brushing. Then polishing. So polishing yields glossy surface and is used on metals like stainless steel, aluminum and copper. It can serve as a final finish or preparation for other finishing operations such as plating. Then powder coating will be there. Different type of powder coatings also we can apply upon to the surface according to our requirement to change chemical properties also. Then plating. So here you can see powder coating and plating will be there. So plating can be done electrolytically or electroless for various purposes according to our requirement. It can inhibit corrosion, improve solderability, harden a surface, prevent wear, reduce friction or aid paint adhesion. So plating process for sheet metal include passivation, chromate coating, anodizing, zinc, again nickel coating, nickel plating, tin plating. Different operations according to our requirement we are going to perform, and whatever that mechanical properties and chemical properties we require, according to that we need to select here finishing operations and we need to perform that. So I don't want to drag this video. So if you want, just you can read or you can just make a note. So it will be important for you. So then design consideration. This is the main part as a design engineer we should know. So design considerations, first we are having parts with hole. Let's say for example one any sheet metal fabrication part we are having with holes. Here you can see punching and laser cutting operations are advisable before forming parts that are meant to have holes. It would prevent misalignment or distortion during deep drawing and bending. So here when we are having parts with holes, after making punching and laser cutting, at the end we need to go for holes. Why? Because before only if we make any holes and while making punching or forming, that holes will get dragged at end and it will become different shapes. It will make misalignment. So better holes should be done at last. Then complex geometries we can't do. So here progressive dies or multi-step forming processes may be required for intricate shapes. As we have discussed earlier, if we are having intricate shapes, so that will improve little difficult. We can make it, but it little difficult it will be, and finishing also we won't get accurate. Then bend radius. The minimum bend radius, as already we have discussed here, just you can read it. Hole placement we have discussed. Then relief features. What are the different type of reliefs like rectangular relief and circular relief. Then material flow will be there. So just you can read it. Then so that is about these design considerations and basic introduction for sheet metal design. So sheet metal is nothing but it is like very vast subject. So if you go again in detail, again it will take more time. So whatever important things are there, just I have covered in this tutorial. So if you feel this video is informative, please share to your friends to whom it will be useful. Thank you so much.